Welcome to the Explainer. So today we're taking a pretty huge leap. We've spent our previous lessons simplifying algebraic expressions, gathering up our like terms and mastering the distributive property. But now we finally get to the true magic of algebra, actually solving one-step equations. Okay, let's just dive right into this.
Here is our blueprint for the balancing act today. We'll be going over the secret of the algebraic scale, the golden rule of solving, addition and subtraction equations, multiplication and division equations, and finally, we'll expose some common traps to avoid.
All right, Section 1, the secret of the algebraic scale. We're going to turn this abstract math into a real, physical concept.
To deeply understand algebra, I really want you to picture an equation, not just as a bunch of boring numbers on a page, but as a physical, delicate, two-pan balance scale. An equation is simply a mathematical sentence that contains an equal sign. And that equal sign, it is the exact center point, literally the fulcrum of our perfectly balanced scale. It tells us that the right side perfectly balances and equals the left side. If they aren't completely equal, well, our scale crashes. So, what's our ultimate mission here? It's simple, really. The goal is to isolate the unknown variable completely on one side. Whether that unknown is an x, a y, or literally any other letter, our absolute objective is to get it totally by itself. Why? Because once that variable is sitting alone on one side, whatever is left sitting on the other side is its true numerical weight. Moving right along to Section 2, the golden rule of solving. This is the pure logic behind our balance. I want you to really let this rule sink in. Whatever you do to one side, you absolutely must do exactly the same to the other side. True equality requires identical actions. If you take weight off the left side of your balance, you must take the exact same amount of weight off the right side. No exceptions. Now, to execute this rule without failing, we use a little toolkit called inverse operations. These are our specialized tools to remove unwanted numbers. It's all about opposites, really. Addition is the exact opposite of subtraction, and multiplication is the opposite of division. We use these opposites to deliberately undo whatever math is trapping our variable.
Okay, Section 3, addition and subtraction equations. Let's actually put this golden rule into practice. Let's treat this like a mini rescue mission. We need to solve x plus 5 equals 12. Step 1, identify the problem. Our variable x is trapped by a plus 5. Step 2, time to apply our toolkit. The inverse operation of adding 5 is subtracting 5. Following our golden rule, we subtract 5 from both the left and right sides. 12 minus 5 brings us to step 3, discovering our final result, x equals 7. Boom! We've successfully freed the variable.
Now, to verify our work, we check our balance. We take our answer, 7, and substitute it right back into the original equation in place of x. Does 7 plus 5 equal 12? Yes, it absolutely does. That proves our answer is correct and our scale remains perfectly balanced. We apply the exact same logic for a subtraction equation. Mission, solve y minus 3 equals 10. Step 1, identify that y has 3 subtracted from it. Step 2, the inverse of subtracting 3 is adding 3. So we add 3 units of weight to both sides to keep the scale level. On the right, 10 plus 3 gives us our step 3 result, y equals 13.
All right, time to level up. Section 4, multiplication and division equations. We're leveling up our balancing act here.
Let's break down this multiplication example. Solve 4x equals 24. Now, step 1 is actually where a lot of people stumble, so recognize that 4x actually means 4 multiplied by x. That 4 is called a coefficient. Step 2, we need the inverse. The opposite of multiplying by 4 is dividing by 4. So to isolate our x, we divide both sides of the scale by 4. And in step 3, 24 divided by 4 reveals our final, completely isolated result, x equals 6.
Now what about division? Let's tackle this one. Solve x divided by 3 equals 5. Step 1, recognize that x is being divided by 3. Step 2, time for the inverse toolkit. We multiply both pans of the scale by 3 to restore the variable to its full value, completely canceling out that division. On the right side, 5 multiplied by 3 gives us, step 3, x equals 15.
Which brings us to Section 5, common traps to avoid. Please, whatever you do, don't break the scale. We are officially entering the danger zone. These are the exact pitfalls where teachers love to trick students on exams. First massive trap.
confusing a subtraction sign with a negative coefficient. If you encounter an equation like negative 3x equals 15, do not, I repeat, do not just divide by a positive 3. Remember, our variable must be entirely alone and positive at the end. You must divide both sides by the entire negative 3, giving you x equals negative 5. Second trap, and honestly the most common error of all, is applying an operation to only one side of the equation. If you subtract 5 from the left side but completely forget to do it to the right, you instantly break the balance of the scale. Absolute equality is required.
And wow, that brings us to the very end of our balancing act. Now that you've mastered the single step, are you ready to balance any equation? Think about it. You have the blueprint, you know the inverse operations, and you deeply understand the golden rule of that physical balance scale. This single-step mastery is the solid foundation you're going to rely on as we bridge into our future multi-step algebra journeys. So keep practicing, keep that scale perfectly balanced, and I'll see you in the next explainer.